Bismillahirrahmanirrahim. Greetings. This is going to be the third video lecture of a mini-series that I'm uploading about the concept of rate, ratio, and proportion. Now, initially we were given a problem that we did not have the faintest idea how to start for the solution. Now, in this lecture, we are going to, one of the advice that was given to us was that to seek, that's in fact a good strategy, to seek for a problem that is familiar to us, the problem that is a smaller, simpler, and we know the answer of that, and use that one as a kind of prototype to lead us, to help us to solve the hard problem. And that's exactly what I intend to do in this lecture. So let's get started, shall we? Now, let me zoom. I don't have somebody behind the camera to zoom in and out for me, so I'm doing that myself mechanically. Please bear with me. Now, a club has 15 members consisting of the male and female in the ratio of 1 to 2, respectively. Now he's asking, determine the number of male and female in that club. Now I already know the answer, but the problem that was given to us was that the enrollment of the college had 25,410 enrollment consisting of freshman, sophomore, junior, and senior in the ratio of 4 to 3 to 2 to 1. That was the initial problem. And that 25,410, I shrink that one to 15. You see that? A simpler problem that is much easier to handle. And then I put the ratio of them is 1 to 2. What we do know is that the ratio of the male to female in that club is 1 to 2. So it can be 3 to 6, the population in the set. Could be 10 to 20, 10 male, 20 female. Can be 50 to 100. We don't know. What we do know is in the ratio of 1 to 2, which means it's going to be a multiple of the ratio of 1 to 2. We want to know what that multiple, that constant multiple is through simple examples like that. Okay, now I have made a model, pictorial model for myself that can lead me to a numerical setup. So let me hang that one up if I may, and zoom in and go over that and see how that picture can help me to set up the corresponding numerical interpretation of that in a sense. Let me zoom in if I may. Looks like it's zoomed good. All right, now my set consists of 15 male and female in the ratio of 1 to 2. Let me say a few words about the concept of cell, if I may. Set and subset in mathematics, they have their own meaning. Set is a well-defined collection of objects. As a matter of fact, set is among the undefined terms, is undefined. But set, one of the properties of the set is that it cannot have a repeated element. If there is a repeated element, then we do not call it set in mathematics. We call it a collection, or we call it population, or even sequence, or it cannot be set. So if there is a repeated element, now in my collection, there are a lot of repeated elements because I'm talking about gender. Now if I would have been talking about the height or about the weight, then yes, I could say, I could use the word set, because there is no two people in the world that they have same height or they have same weight. Everybody is unique, it's like fingerprint. Huh? But I'm using, again, I repeat myself, gender, so I should not use the word set as far as the mathematical meaning is concerned, but I'm using to convey the idea. So that is like an ordinary conversation that we are making, and not as a mathematical, rigorous mathematical meaning of that. So please keep that one in mind. Thank you. Now going back to this, what I do know about this this set of 15 members, that they are in the ratio of 1 to 2. So I take that premises and I partition this set into subsets of each subset consisting of 1 male and 2 female. And I end up with 5 of them. 1, 2, 3, 4, 5. You follow me? Now I notice that 5 male, you see 5 male is there are 5 male, and 5 times 2 there are 10 females here. There are 5 cells, each cell has 3 elements, 1 male and 2 female, so there should be, the entire population should have, how many? Should have 5 males and 10 females, and that ends up to be the case. I put it here for you. Huh? So far so good, huh? Now let's see and how we can transfer this pictorial interpretation to numerical representation of them. How can we come to a corresponding numerical representation? So let me see. That's good. Looks like it's zoomed good. Now, in our pictorial demonstration, we partition the set of 15 male and female into 5 subsets. We just passed that. And each consisting of 3 members of the set, 1 male and 2 female. They were in the ratio of 1 to 2. Is that right? Now, the numerical correspondence looks like to be 15 divided by 3 equals to 5, because we had 5 subsets. And that is same as 15 equals to 5 times 3. Is that right? This is the kind of we represent numerically. Now, this raises the following question. How are we going to interpret this numerical representation? How are we going to say, because we are dealing with numbers, how are we going? So I have 2 answers for that, and we go further for that. Let me put the answers up and we discuss it. So remember the question, we are dealing with numbers, and we want to know how we can interpret that number. Now, the answer of that question, one of them is, another question is that how many subsets, each having 3 members of the club, can be formed from the 15 members? This is one answer to that question. Itself is a question. Now, this is a combinatorics question. The science of combinatorics answers that, and the answer of this one is 5, it's like previous one, but that 5 is not unique. And the subsets will not be, each of them, equivalent to one another. Only one of them, in fact, will be. So the science of combinatorics answered this one, but this is not what we are after too. Because the number of 3 can represent 3 males, can represent 3 females, and can represent 2 male and 3 female, and etc. Now the second question, that is the answer of our of our question is that the second one, which is also a question but is the answer of our question, is that how many subsets, each having 3 members, all right, consisting of 1 male and 2 female, can be formed according to our pictorial demonstration. That answer was 5, and we want to see how we can achieve that number, that 5 numerically. It looks like if we divide 15 by 3, we get 5. And 3 is the number of members in the bot, in the number of members in the subset. So let me zoom this back so that I can discuss it. You see here, we have 15 divided by 3. 15 divided by 3 is 5. That's correct. But what is 15? What is 3? What is 5? They are pure numbers. And what is number? Number is abstract and is adjective in reality. You know, when you say good man, good by itself is a noun. It has no meaning. But when it is attached to a noun, man, then he gives the quality of that man, good man. And the very same is true with numbers. 5 by itself is abstract. But when we say 5 apple, when the noun of apple is called, then 5 is going to give the quantity, describe the quantity of the apple. So it's adjective. It gives the quantity rather than quality. So when we say 15 divided by 3 is a number. I don't know what that stands. 3 can be 2 plus 1. 3 can be 1 plus 1 plus 1. 3 can be 2.5 plus 0.5. Infinitely many different ways of 2 or 3 numbers we can add to come up with 3. So we have to know what goes with that. So with the assumption that our 3 are, we can write 3 in 1 plus 2, and with the assumption that that 1 stands for male and 2 stands for female, with that assumption we come up to see 15 equals to 5 times 1 plus 2, which is 1, which is 5, plus 5 times 2, which is 10, and that's exactly the number of male and female were in our in our club, and they were in the ratio of 1 to 2, 5, because it ended up to be 5 to 10. Looks like that from this example, we have got the idea. We can use that one as a prototype to go and solve the initial problem that was 25,410 enrollment in the college, and come up with the answer. But I would like to make another example similar to that, and so that we are kind of more convinced, and then generalize the idea, which means we are going to come with a deductive mathematical formula that we can use it for all similar problems as this one, so that we don't have to each time to go through the pictorial and demonstration and come up with the answer. We can generalize the idea. Okay, then, the matter of fact is that mathematics is a science of think, reflect, and is a science that improved our critical thinking. So to follow the recipe, cookbook style of recipe belongs to the kitchen. Do this and this and this, get that one. That is not mathematics. As a matter of fact, that is the cause of the anxiety for mathematics, the recipe following. But this kind of technique that you discover for yourself is what mathematics is all about, and train us. And once you become skillful on that, is fascinating subject. It's very, very interesting and sweet. Okay, then I thank you all very much for watching. I hope that this lecture was beneficially, and I repeat myself, in the next lecture I'm going to generalize this idea and make another example so that we are more comfortable and see, yes, that is the way it works. So instead of 3, you can write 1 plus 2, and why we write 1 plus 2, not 2 plus 1, and not why we wrote 1 plus 2 and not 1 plus 1 plus 1 or something like that. Okay, then I thank you very much all for watching, and as always I wish you all prosperity and good health, and please stay and remain safe. So long.